Hello. Thank you for joining us at the 2022 Android Developer Summit. It's exciting to be here in person with so many of you and able to wave hello to everybody on the live stream. Today, we're going to talk about 3 themes that we're seeing across the Android ecosystem. 1, modern Android development. 2, building for a multi-device world. And 3, the latest improvements to the Android platform and getting it into users' hands. But first, allow me to introduce myself. I'm Matthew McCullough, and I lead Android's developer organization. We build the APIs and tools that you use in turn to build your apps. I'm new at Google and what they call a noogler, but I've been building developer tools for about 20 years. And I care so deeply about making developers like you more productive. I love how that productivity gives you more time to be creative and helps you build delightful experiences for your users. One of the reasons that I'm so excited to work on Android is the unique Android developer community. It's a network of resources and skills and sharing that contributes to helping one another build great apps and serve the greater Android community. For an example of what your Android community makes possible, look no further than Ahsan Aman, a student from Pakistan. After his mom received a counterfeit banknote, a big problem in rural Pakistan, he set out to build a fake note detector. With the help of his local Google Developer Student Club and supportive online Android developer community, he was able to create an ML-powered Android app that fulfilled that vision and is now working to scale the idea. Another example is the Android Developer Hangouts and weekly Twitter Spaces hosted by Google developer expert Madonna Wambua and Matt McKenna. It's great. Yes, round of applause. It is really great to see them creating a space that brings the Android developer community together to share knowledge and help each other in an environment where everyone feels valued. And lastly, Android Developer Summit. This event is literally an expression of this community, bringing it together and sharing stories, giving shared learning, and bringing an opportunity to give feedback to product owners. Talking directly with you and hearing your perspectives helps us make Android better for everyone. So let me share a bit more about the 3 themes that we're seeing across the ecosystem and want to explore with you today. First, the platform. We're evolving the Android platform to meet users' demands for privacy, security, and personalization. We see apps and the Android platform as symbiotic and are working to enable you to build amazing apps on top of it. And we know that you want to use these features sooner, so we're working to make them available on ever earlier Android releases. Second, modern Android development. Users' demands of apps have grown, and in fact, they expect rich, dynamic, delightful applications. We want to help you build those by easily shouldering the complexity and providing powerful building blocks and sharp tools. Third, form factors. We're seeing people owning and using multiple Android devices and are expecting apps to work across them seamlessly. They want their devices to be better together and uniquely leveraging each form factor for exactly what it does best. We're seeing especially strong growth in wearables and large screen devices, and we want you to be enabled to build for those opportunities. So without further ado, let's dive into the technical content. Please welcome Romain and Florina to take us through the latest updates in modern Android development.
A few years ago, we introduced a set of libraries, tools, and guidance that we call Modern Android Development, or MAD. And our goal is to make it faster and easier for you to build high-quality apps across all Android devices. And that's why we brought you Android Studio and Kotlin, and a bunch of Jetpack libraries, powerful Google and Play services, documentation, code labs, and a lot more. And we're always investing in every single part of the app development experience to simplify it and keep you productive, so that you can focus on what matters the most to you, your apps your business, and your users.
We want the skills you learn to be applied across the entire ecosystem of Android devices. For example, we believe that Jetpack Compose is the best way to build rich, beautiful UIs. Compose already lets you ship delightful experiences on phones and tablets. And earlier this year, we released Compose 1.0 for Wear OS, making Compose the recommended way to build wearable UIs. Compose is now taking the next step, and I'm glad to announce the first alpha release of Compose for Android TV. Components like Feature Carousel and Immersive List are already available, and more are coming soon.
And we've heard from you that Compose is changing the way you're building apps. It's reducing the number of bugs and increasing your development speed. So now, over 160 of the top 1,000 apps on the Play Store are already shipping Compose. That's a 50% increase since Google I/O earlier this year. And it's been great seeing apps like Cash App saying they're going to use Compose for all their new features. But what's been even more amazing is seeing the reaction across the community and witnessing the incredible creativity of everything that you've been building.
But we know we're not done. So far, we released all Compose libraries together since 1.0 a year ago. But we wanted more flexibility so different Compose libraries can move at their own pace. So we started versioning each Compose library independently. To make it easier for you to manage your dependencies, we're now introducing a Gradle bill of materials, BOM for short, that specifies the latest stable version of each Compose library. We'll, of course, update it for every stable Compose artifact we publish. Our first BOM release, Compose October 22, brings many new features like lazy stagger grids, custom lazy layouts, filter refresh, variable fonts, and performance improvements. For example, in this release, we started a major refactor to the modifier system to improve performance. We've been able to introduce this without touching public API due to the solid layering and abstractions that Compose is built upon. We're focused on making Compose performant out of the box so that your apps are buttery smooth.
And that's not all. A year ago, we introduced Material U with Android 12, Google's most expressive and flexible design system. And now, Material 3 components for Compose are stable, and you can start using them to build fresh, beautiful apps that put your brand front and center. With Compose, you can write dynamic, efficient apps across a wide range of form factors. So we believe that you should use Compose if you are new to Android or starting a new app. And to help you and your teams on this journey, we recently updated our Android Basics training course and launched a series of Compose Camp events to help you learn Compose.
Okay, enough talking. Let's start showing. So, I'm using here the latest release of Android Studio Flamingo, and I'm just creating a new project using the defaults. Okay, so usually the first thing I do when I open a project is check out my dependencies. So I'm going to go to my build.gradle file. And then here we can see that Compose is the default whenever you're creating a new Android project. So we talked earlier about the BOM. Let's see it in action. So here I'm importing the BOM. So this means that now I can just do this. And that's it. I can remove the versions. OK, we just have a grading here. Let's build some UI. So I'm going to add some code, and then I'm going to replace my greeting with my screen. And then let's see what we have here. So in my screen, I have a scaffold, and then inside I have a large top app bar, and then in my screen content, all I have is a text and a list of items.
Of course, the preview is great, but we also want to check what the UI looks like on a real device. So Florina just moved to the running devices pane, and now she's plugging in her Pixel phone. And with the new device mirroring feature, we can see and interact with the phone display directly from within the IDE. So now I'm running the app, and I can directly just scroll my list from Android Studio. So this looks OK, but I think this would look much better if the top app bar would collapse. Well, with the new Material 3 APIs, I can do just that. So I'm adding a scroll behavior,
And then in my scaffold, I'm connecting the scroll behavior. And then in the top app bar, I'm assigning the scroll behavior to the top app bar. OK, this is much better. So now I can see how the top app bar collapses, and I can see more of my screen. Okay, next, I want to show you one of actually my favorite features from that are available in Compose 1.3. So I have this text here, and wouldn't it be cool to show this as a gradient? So to do that, I'm first going to add my gradient. And then all I have to do is, in the text style, add a brush. And then in the brush, use my linear gradient. And then, yeah, I can see the gradient.
And you can see that we also have a scroll to top button, and the visibility of that button depends on the index of the first visible item in the list. So when you do a state read like this in Compose, you can create unnecessary composition, which can be bad for performance. But thankfully, we have tools to help you there.
Yes. So in the layout inspector, now we're able to see the recomposition count. So like how many times a composable has recomposed. OK, let's try again.
It worked great during the rehearsals.
Let me see. I'm going to switch to the other machine quickly and see.
We also have studio folks in the room. Maybe they can come debug it.
So I'm just going to add my stuff. Replace this and this.
Can we switch to the other machine?
This is great. Let me switch the actual phone as well.
At least you know it's real. Unless we're faking that as well.
And in my running devices, yeah, I see the pixel. And
see, that's one good thing about the device mirroring feature. If you have to change the machine, at least the app is still running.
OK, let's see. What does the layout inspector do now? Yeah, there we go. So now, if I'm going to my animated visibility, because this one is the one that depends on the show button, and then I'm scrolling, I can see how the number of possible recompositions is increasing here. I don't know why you're clapping. That's not what we want. We don't want that number to be that high. But luckily, Lint actually also has my back, because it tells me frequently changing state should not be read in composable functions. But not only that, it also tells me the solution. So I should wrap this with derived state of. I'm just going to replace this one here and make this a delegate. And then I'm going to inverse it and get value.
I see some people are used to that one.
OK, so now if I'm scrolling and going to my button, OK, let's see. This is the time where you're supposed to clap. We know that you want your apps to be as smooth as possible. But understanding and fixing performance issues can be tricky. So we're adding tools and libraries to help you.
And of course, Jetpack is a lot more than just Compose. Our goal is to assist you in building and improving every part of your app with regular updates to our core library. So here are a few examples. Benchmark 1.1 helps you monitor the startup and runtime performance of your app with the introduction of macro benchmarks. And in Benchmark 1.2 Alpha, you can now measure the power usage and have detailed composition timings in your Compose code. Fragment 1.4 brings a new strict mode to automatically catch common issues about fragments. And Activity 1.6 adds support for predictive back on Android 13. And if you're already using the Jetpack fragment and navigation libraries, you don't have anything to do. It's fully automatic as soon as you upgrade the libraries. And I wish I could tell you about all the changes and improvement that the team has been making over the past few months, but I would like to focus on performance. The best performance improvements are the ones you get for free. And baseline profiles are a powerful way to improve the startup and runtime performance of your app without changing a single line of code. Using baseline profiles, you can improve startup time by up to 40%. So we are making generating baseline profiles easier with macro benchmarks and AGP 7.3. And to learn more, I encourage you to go to watch the talk, I think that's right after the keynote, called Making Apps Blazing Fast with Baseline Profiles.
Finally, we know that building an app is more than just writing code. And that's why we introduced App Quality Insights earlier this year. This feature, available in the latest version of Android Studio, allows you to see crash reports from the field and navigate to the offending code, all from within the IDE. Now available in the beta channel, App Quality Insights goes further and helps you communicate the status of issues with the rest of your team. You can filter issues by play track and quickly identify new ones requiring action. By quickly adding a note from your IDE, you can let your team know that you're on it. And then when the problem is fixed, just close the issue.
You know, there's that joke that everybody's adding stories to their product. It feels like we're doing just that. So I don't know how to feel about this. Anyway, that's the latest from MAD, with Jetpack and Compose updates, new tools, extended guidance to make it faster and easier to build great apps across devices.
Now, let's see how Zepeto shipped their app faster with Compose, and then we'll hear from Viki and Sara on the latest on Wear OS.
Zepeto is a 3D avatar service that has captured the hearts of over 300 million users in over 200 countries. My name is Ho-Jun Kim and I'm an Android developer working on Zepeto. We decided to adopt Compose as we were looking for a better way to build UI. They embed scope for the coroutine, so I think Compose has a good combination with Kotlin. Compose enabled us to build a design system with organized fonts and the size in a more intuitive way and help us build more efficient code. So far, there are 330 preview functions in the project. We implemented Compose across many features. We wrote the character shop feature in Compose. It was much faster to write the feature in Compose. And we reduced the amount of code by over 10%. We rewrote our dialog component in Compose and were able to clean up more than 1,600 lines of code, which makes it easier for us to maintain. Compose reduced our development costs. Migrating to Compose dramatically reduced the time required for UI debugging. Compose simplified our UI layer logic, making it easier to understand code written by my colleagues. Compose is very easy to learn. Compared with previous Android view systems, Compose was much easier to use. The person who wanna use Compose, the person who hesitated, I wanna say, just try it.
Folks, let's take a look at the smallest and most personal Android device, the watch. It's a growing target for Android developers as wearables become ever more popular with users. Just last year, we launched our joint Wear OS 3 platform together with Samsung. And this year, we've seen 3 times as many device activations. We've seen beautiful new devices this year from Samsung and from Montblanc, Fossil Group, and Mobvoi, all powered by Wear OS 3. And earlier this month, we at Google launched the Pixel Watch. It's our first ever smartwatch. It brings the best of Fitbit and many of your favorite Google apps to your wrist. All of this progress has resulted in really exciting opportunities for your apps.
Wearables bring something completely unique to Android. There are sensors like heart rate, and there's payments and notifications right on your wrist. Making the most of the different wearable surfaces can increase users' engagement with your app across all devices.
Sometimes you'll create a full app, but you might want something more immediate, like a tile for a single task, or a complication that stays directly on the watch face. As you design, consider what really works on the wrist. Focus on a few simple user journeys that add value and can be achieved with short user glances and quick touch, or voice interactions.
There are many tools and utilities in Wear OS and in Android Studio that make it easy to create each of these options. Let's take a look at developing the app. To make it faster and easier to build apps for Wear OS, we announced the Compose for Wear OS 1.0 release this summer. This means that the API is stable and it has everything you need to build production-ready apps. Going forward, we recommend using Compose for Wear OS to build your Wear OS app. So let's jump in and see how it works. It's really simple to create a beautiful Wear app from scratch. So I'm opening up a project I've been working on in Android Studio. I used a Compose template to get started on building a swim tracking app, because I always lose track of my laps.
Sara is setting up the scaffold component that's tailored for the watch. Scaffold fits the time at the top of the screen and puts a progress bar on the side and keeps content perfectly centered. Compose for Wear OS has more than 20 UI components specifically designed for wearables, like time text and position indicator that we're using here. And there's even more in the Horologist library. That's our open source incubator project. These components help you develop for all Wear OS device sizes with minimal code. Now we have the scaffold in place, let's add some content. Scaling lazy column. It's one of our favorite components, despite its name.
You can add chips or cards or other components that are specifically designed for the wearable screen into the scaling lazy column. We already created some, so I just added those in.
As you'll see, scrolling the list shows a subtle fisheye animation, and the list handles content padding for any watch size with no extra work. You can see the time stays fixed to the top, and the progress indicator on the right shows the scroll state.
Now that we can scroll, and remember that default material theming is automatically applied, like this ripple effect, and you can easily add additional customization.
And of course, standard Android Studio tools work for Wear OS too, like the emulator and live edit, and the preview tool we've shown here. So you can directly deploy to a live Wear OS surface and see the results as you work.
So now that we quickly built out our UI, let's see how we could connect this to the device's sensors. We'll use health services, which is now in beta. So first I'll declare the exercise type. So here we want swimming. And then I'll go ahead and add the data types that we're interested in.
The Health Services API makes it simple to build power-efficient apps that use data from any device sensor and from a range of calculated metrics. It's our recommended approach for building health and fitness apps. Long battery life is one of the most important things for wearable users, and Health Services is optimized for power efficiency across all Wear OS devices. So you can gather high-frequency sensor data without draining power too fast. And you can get data from complex metrics without having to write complex code.
So now that I've added all these metrics, like we have heart rate, GPS, and even swim laps, I'll go ahead and connect this to our UI and we can start tracking. Then our app can easily collect health and fitness metrics without sacrificing any battery life.
So we've collected all this personal data from our sensors in our Wear app. Now we want to record and analyze the data over time. But how do we store the data and share it with other devices in our Android ecosystem? And how do we still keep it completely private and safe?
We've been working on a solution to make this easier, Health Connect. It's an API on the phone that we built in close collaboration with Samsung. It's a unified API for storing and sharing health data, all while giving users a single place to easily manage their permissions. So here's an example of inserting the data that we've collected into Health Connect. Once your watch app collects data, send this to your phone app and write it into Health Connect so that it can be shared securely with other apps in the Android ecosystem. Your mobile app can read data from other apps using Health Connect as well.
Wearables are a core part of the Android ecosystem, and we're constantly improving Wear OS as a developer platform. Android developers are already producing great apps for the fast-growing Wear OS user base.
Many of the developers we've been working with have seen Wear apps increase user engagement and have used our tools to reduce development time. Todoist increased their rate of installs by 50% since rebuilding their app for Wear 3. And Outeractive reduced development time by 30% using Compose for Wear OS. Some things that used to take days now just take hours.
So today, we've seen how Compose, health services, and other Wear OS features make it easier to develop for the watch. So you too can extend your app experiences to reach the growing number of Wear OS users. Check out our updated Wear OS landing page to see code labs, design guidelines, case studies, and more. Try out Wear OS development for yourself. It's so worth your time.
And now let's take a look at how Strava increased user engagement with Wear OS before handing it over to Daniel and Diana for the latest on large screens.
My name is Dave Rosenai. I'm an Android engineer at Strava, and I've been there 7 years. Strava is the leading platform for athletes. It's the world's largest sports community with over 100 million athletes in 195 countries. If you sweat, you're an athlete, and Strava's mobile apps and website connect millions of active users every single day. Investing in wearables helped us take our product and experience to the next level. Recording a run, a ride, a hike, or any activity is not convenient with your phone. For users wanting to take their experience to the next level and invest in a wearable, we wanted to bring the best of Strava to their wrists. With Wear OS 3, we let athletes access the Strava experience on their favorite wearable device. They can record over 15 sport types with real, live-time performance metrics and stay safe with our Beacon safety feature that allows real-time location sharing with friends and family. And with Wear Health Services battery optimizations, they can record activities longer than previously possible. Unfortunately, living in busy areas, GPS signal is not always the best. With Google's latest technology, we're able to fall back on other sensors to compute distance when GPS signal is lost. This is a big win for our experience and accuracy for athletes' activities. Nothing is more frustrating than uploading a run or ride and having it be inaccurate. Tapping into Google's APIs, libraries, and Android tools enabled us to save time and let us take care of the little pieces, the details that'll make the experience authentic and true to Strava. Overall, we've seen Wear OS significantly impact athlete behavior on the platform. We saw increases in activity level with 25% more activities for those with a wearable versus without. Wearable users on Strava had over 30% more active days on Strava versus users who did not use a wearable. Wear OS has made major improvements. The hardware is considerably more capable, the APIs and UI libraries provide building blocks to speed up engineering, and the development tools make the process easier than ever. You can learn more about how developers like me build Wear OS apps by heading to developer.android.com/wear.
We're continuing our big changes to help apps expand to large screens like foldables, tablets, and Chrome OS. These devices are driving a generational hardware shift, changing the way users interact with Android apps on any size screen. New devices like the Samsung Galaxy Z Fold 4 and the Lenovo P12 Pro showcase recent OS updates like updated tablet UIs, the taskbar, and updated compatibility modes. Here at Google, we're getting really excited. Earlier this month, we showed a preview of the upcoming Pixel tablet. Arriving in 2023, it's bringing the best of Android and Pixel together in a tablet. And over 50 of our most popular Google apps have been shipping updates. From Photos to Chrome to Gmail, these updates are now available in the Play Store. As you explore updating your app, we're making it so easy for you to see how your app works, even if you don't have the device. Let's take a look.
Android Studio has new emulators that the Google Keep team used to rapidly iterate on their new large screen layouts. To quickly test apps on a variety of representative devices, Android Studio now includes the experimental resizable emulator. With this, you can toggle between reference devices, representing a typical phone, unfolded display, and tablet. Additionally, if you want to test your application on Chromebooks, we have a new desktop emulator as well. By default, launching your app in this emulator launches it in a freeform window, allowing you to resize the window to any size you'd like. Keep is just one example of many that has been able to leverage the power of Android Studio to build great large screen experiences.
The Play Store app is also making updates to provide a better experience for users on large screens. We're redesigning the store listing and home pages with beautiful layouts that show off how awesome an app can be on the larger screen. As you work to optimize your app, updating your listing with screenshots and videos means you can take advantage of these richer formats. We're also making changes to help users find high-quality apps. On these devices, ratings and reviews will be specific to users on tablets and Chrome OS. Apps that support large screens will also be easier for users to discover in personalized recommendations, collections, and editorials. And optimized tablet apps will be available for users to browse and install across devices, downloading an app to their tablet directly from their phone. With these opportunities in the Play Store, we're excited to see many apps taking advantage of large screen-specific layouts and use cases. Canva has added updates like drag and drop when there are two apps on the screen to create new files. And Concepts enables amazing stylus interactions like drawing and shape guides for Chrome OS and stylus devices. They see a 70% higher usage on tablets compared to phones. We've learned so much from developers like you around how your app can take advantage of the larger screen, that today we're launching a new gallery on developer.android.com with app designs and guidance. This includes high-fidelity mockups, links to material design guidance, implementation guides, and case studies from real apps. We have examples of how a media app can scale video playback, or how shopping apps can display more products as the screen expands from a phone to a desktop device. If you want to know how to implement messaging responsively and get examples of what it should look like, you start here. Beyond the guidance, we've also got more tools to help you identify design issues. Let's see how.
We know it can be challenging to stay current on best practices. Don't worry, we're bringing that info directly to you in Android Studio. Switch over to the next demo. Here's an app we built with views using sliding pane layout. Updates to the layout editor now show me the same 4 reference devices you just saw in the resizable and the desktop emulators. By designing the UI to work well across these 4 reference devices, your application will look good in nearly all display sizes. While reference devices in the layout editor ensure I don't need to own every single type of Android device, I still want to keep up with evolving UI best practices. One of my favorite new Android Studio features is the new visual lint feature provided in layout validation. Let me go ahead and open layout validation. We built this tool to flag the most common large screen UI issues directly in the IDE. For example, here's a warning recommending that I use a vertical rail instead of a bottom bar for navigation on larger devices to improve reachability. Let's go ahead and fix this in my large screen layout. First, I'll add the nav rail, and I will adjust the margin of the content to account for the new nav rail. And then I will remove the bottom bar, whoops. And voila, I can see the warning has gone away, and I can quickly preview the updated UI on each of the respective devices.
So updating the nav rail and 2-pane layouts are a great first step that we've seen many apps adopt. Facebook has recently updated to a vertical navigation rail with a tablet layout, as well as the ability to launch Messenger from Facebook directly into split screen. Instagram and WhatsApp have also recently added tabletop mode for video calling on a foldable. Whether you're working on an existing multi-activity-based application or building a new app with Jetpack Compose, we're working to make updating layouts less work. We've released new APIs like activity embedding, window size classes, and Jetpack Compose support to make it easier to build responsibly. Speaking of Jetpack Compose, let's see how Android Studio can help Compose developers.
Switch over to the Compose app. So the Now in Android app is a sample built with Jetpack Compose and Kotlin that shows recent Android developer news and updates. As part of the stable Material 3 Compose release, we have a new library that provides the easiest way for Compose developers to adapt layouts to window size classes. With just a single function call, I can get my window size class layout breakpoints, where I can then use Kotlin conditional logic to determine or to change my Compose layouts. You can use these breakpoints directly in your Compose tree Or you can set Boolean values, as we've done here, to determine which navigational element to show, such as only showing the bottom nav bar on compact displays. Additionally, with Compose, the same 4 reference devices you saw in the previous demos are here as well, this time with the Compose multi-preview feature. This lets you configure your multi-preview configuration just once and reuse it in all your layout previews to detect and fix UI issues impacting all screen sizes. Throughout your development journey, we're making it easier for you to support all screen sizes within your existing workflow.
So, with our upcoming devices, Play Store changes, new guidance, and updated developer tools, we've got so much to help you update your app for large screens today. Now, over to Charmaine and Dan to tell us about what's new in the Android platform.
With updates like the taskbar, activity embedding, and compatibility mode, Android 13 delivers an even better experience on tablets. But there's so much more to Android 13, with enhancements to personalization, privacy, security, connectivity, and media. More importantly, we're using a variety of technologies to allow you to deploy these features to earlier Android releases. Dan and I will walk you through some of the many ways you can take advantage of these technologies. Starting with personalization. The world is multilingual, with people often communicating in different languages in different contexts. With Android 13, we've introduced per-app language preferences to improve the experience for multilingual users.
All right. I'm going to reset my Git demo here. So we are going to go back and start demoing here. Let's see if we can actually get this to run for you guys. So enabling per-app language preferences for apps running on Android 13 involves adding a locale config XML file and a locale config attribute file in the Android manifest. Now, this means that Android users on Android 13 get the setting in a very consistent and discoverable place, but we can do better. And building a custom in-app language picker that synchronizes with Android 13 settings like Google Maps has done gives Android 13 users the best experience while letting everyone use per-app language settings. All right, now to the demo. Now, I've added some language-specific resources to the Affirmations app from our Android Basics with Compose class, along with a Compose custom language picker dialog. Now, I've implemented this using the Android 13 APIs, but the app-compat version is actually even simpler, and it provides backwards compatibility. So I just changed this to locale list compat over here, and this is where we take the locales that we're setting, and then I can call the app-compat delegate to set the locales, then I get rid of all of this, like, SDK version checking that's sitting here, which is cool. And then we actually have to go and make one more change. So one of the cool things that this library can do for us is actually store the locale setting on our behalf. So I just put a service definition here in the Android manifest file, and that will happen. So let's stop this so it doesn't actually say, sorry, you've changed the manifest, and run it again. And now we have implemented a per-app language picker that runs on every version of Android that it supports, and it synchronizes the setting for Android 13.
All right, let's switch gears and talk about privacy. If your app needs to get a selection of the user's images, like when choosing a profile picture or sharing a post on social media, you can call the new Photo Picker API. Using the Photo Picker is a privacy-friendly way to allow the user to select photos and videos they explicitly want to share with your app. And in the upcoming months, the picker will also include media the user has stored in the cloud.
Now, to begin our integration of the Photo Picker, we create a pick visual media request. By registering for an activity result with the pick multiple visual media result contract. And this returns a callback that gets the returned content URIs. So I'll go and set these into my view model. And then we have to actually go to launch this thing. So one of the things we can do is is photo. There we go. Is Photo Picker available? I can do this. I can type. There we are. I've typed. And is Photo Picker available? And then we can launch it with the type of media that we actually want to select. And this can be photos and or videos. So let's run this thing one more time. And with that, the photo picker can actually be used to replace these beautiful images that Romain has with something a bit more whimsical. Now, Photo Picker is supported back to Android 11 using an SDK extension. And this is a technology that uses Google system updates with modular system components to add functionality to an OS release. Is Photo Picker available internally calls get extension version, which, by the way, is how you check for the presence of an SDK extension at runtime. If the Photo Picker isn't available on the device, the support library automatically invokes the action open document intent, which isn't quite as rich of an experience, but also functions back to API 19 without requiring additional permissions. So in many cases, your app will no longer need a runtime permission at all to access user-selected media. Now, new to Android 13, you can also tell Android to revoke any held permissions your app no longer needs. Your longtime users will appreciate how you've been considering their privacy.
Android 13 also introduces a notification permission to give users easy control over which apps can send you notifications. This happens regardless of what API level you are targeting. However, targeting Android 13's API level 33 allows you to improve the user experience, with control over when the permission request happens, the ability to provide more context, and the chance to requery the user. To help you target new API levels, we're introducing the Android SDK Upgrade Assistant tool within Android Studio.
All right, so in the Upgrade Assistant, you select your upgrade path, and then you get this step-by-step documentation for the most important changes you need to consider when migrating. So for example, when migrating to Android 12, you'll see, okay, here's what I need to do for Bluetooth and location and intent filters and important things like foreground service launch restrictions. And what we're launching with Android Studio Flamingo here is just the beginning. We're working to provide contextual filtering along with auto migration to be even more helpful in the future.
With updated Android Studio tools, backwards compatible app compat libraries, and the use of SDK extensions within the platform, we're making it easier than ever to adapt your app to platform changes, while enabling you to take advantage of the latest features Android has to offer. With that, I'd like to invite Matthew back to the stage.
All right.
Hello again. Thank you to my colleagues Florina, Romain, Sara, Viki, Diana, Daniel, Charmaine, and Dan. Thank you very much. From modern Android development to wearables, foldables, and large screens, and from compose to platform updates, even after 14 years, we still have so much progress to share every time we come together for ADS. It makes me feel honored to have been welcomed into a team that works so hard every week to support our developer community. And that's you, ADS audience. We're here to listen and to serve. And we have even more learning opportunities in store. Next up, we have talks themed around modern Android development. And in the following weeks, we'll have a live stream track from Form Factors on November 9th and one for Platform on November 14th. And then we have visits also to Bangalore and Tokyo in the month of December. So join us now and drop your mad questions into the YouTube comments or on Twitter using hashtag AskAndroid. And tune in later today to see if we answer your questions live. From the experiences you build for users to the feedback that you give us to help make our tools better, thank you. We appreciate you taking the time to join us today and look forward to chatting more during the rest of Android Dev Summit 22. Thank you so much for joining us.